this video, we're going to be looking at multiplying radicals. So for each of these, we're going to multiply, and then we're going to write in simplest form. So for this first one, I'm going to go ahead and show you two different ways that you can do it. The first way is to go ahead and multiply first. So I can do 12 times 18. And when I do that, I get 216. So this becomes the cubed root of 216. And then I can do just like what we did in that first video. So I'm going to break this apart. So if I divide that by 2, 216 divided by 2, I get 108. This becomes 2 times 54 is 108. 2 times 27. 3 times 9. And 3 times 3. So I'm looking for triples that can come out because my index here is 3. And so I see that I have 3 2s and 3 3s. And there's nothing left over. And so this would become 2 times 3, which gets me 6. Another way you can do it is to go ahead and actually break apart each of these into their factors. So 12, that can be 2 times 6 and 2 times 3. So I can rewrite this to be 2 squared times 3. 18, that is 2 and 9, and 3 times 3. So that becomes 2 times 3 squared. And then I can combine it from there, and so I get the cubed root of 2 squared times 2 gets me 2 cubed. 3 times 3 squared gets me 3 cubed, which becomes 2 times 3, which is equal to 6. So either way works, whatever works better for your brain. Okay, let's do this next one. I'm going to go ahead and do this second method just so that we're working with smaller numbers. So 27, that can be broken into 3 times 9 and 3 times 3. So this is going to be the fourth root of 3 cubed. 9 can be 3 times 3. So this is going to be times the fourth root of 3 squared. Now if I multiply these, 3 cubed times 3 squared, same base, that means I'm adding the exponents, so this becomes 3 to the 5th power, which is really the same thing as the fourth root of 3 to the 4th times the fourth root of 3 to the 1st. And so that means I get 3 times the fourth root of 3. Okay, number 3 and number 4, I now have some variables that are in there. So I'm going to go ahead and multiply first. So I have 8 times 4, and I get 32. X squared times x to the 4th, I get x to the 6th. Y cubed times y to the 6th, I get y to the 9th. And so breaking apart this 32, I have 2 times 16, 2 times 8, 2 times 2 times 4, and then 2 times 2. So here I see that I have 1, 2, 3, 4, 5 2s, and I'm taking the fifth root here, so that means I'm looking for a group of 5. So I have one group of 5 2s, so that means that I have a 2 that's coming out in front. Now x to the 6, I'm looking to see how many groups of 5 I have. Well, for x to the 6, it's the same thing as x times x times x. So x times itself 5 times, or 6 times. So that means I have one group of 5 x's. So I have one x that is coming out. And there's one x that didn't get used, so there's one x remaining. And then for y to the 9th, I can kind of think that one through. So how many times does 5 go in there? Well, 5 goes into 9 once, so that means one y comes out. And that leaves a remainder of 4. So I have y to the 4th. Again, if you can't think of that in your head, another way you can do it is to write out y 9 times. And I see that I have one group of 5 y's and 4 remaining. Okay, let's look at one last one. So here I have the cubed root of 12xy squared times the cubed root of 9x to the 4th, y to the 4th. So here I'm going to note that my index is 3, so I'm looking for groups of 3 that I could take out. Well, 12 times 9, I get 108. X times x to the 4th is x to the 5th. And y squared times y to the 4th, I get y to the 6th. So breaking apart that 108, I have 2 times 54, 2 times 27, 3 times 9, 3 times 3. So looking for groups of 3 numbers that I can take out, I see that I do have 3 3s, but I only have 2 2s. And so that means a 3 comes out, but inside I still have 2 times 2, which is 4. Now x to the 5th, see how many x's I can take out, how many groups of 3. Well, that is 5 x's. That means I have one group of 3 x's that come out, but then 2 are still remaining. And then looking at y to the 6th, see that I have 6 y's. And so that means I have 2 groups of 3 y's that can come out, so that's y squared, and there's no leftover y's. And so this becomes my answer.